Circle. We're going to do it another method. Method 2. Method 2 is using the bisector method. Now, this is the circle that we find. Now, the bisector method is saying that if you were to find the equation of the line PQ and find the perpendicular bisector of PQ, the perpendicular bisector of this line PQ would pass through the center. The perpendicular bisector of PQ would pass through the center. It would look something like this. And also the midpoint of PQ. It would something like this. All right, where this is the perpendicular bisector of PQ. This is the perpendicular bisector where this is 90 degrees. Also, if you were to find the bisector of the line PR, the perpendicular bisector of the PR would also be a line that looks like this. This is the bisector of PR. All right. So what I want to show you is method 2. Method 2 is you're gonna find the equation of the line PQ, and then you're gonna find the perpendicular bisector of PQ. So I'm gonna call this B of PQ, meaning the bisector of PQ. All right, and then this is the equation of the line PR. Then we're gonna find the perpendicular bisector of PR, and then where the two bisectors meet, they meet at the center. Once you get that, then you can find the equation of the circle. So we're gonna do it this alternate method. Let's do it that alternate method and see. All right. So first thing we're gonna do is, as you can see right here, this is PQ. We're gonna find the equation of the line PQ. So first we need the gradient of PQ. So the gradient of PQ is equal to y2 minus y1, 5 minus minus 4, 5 minus minus 4 over x2, which is minus 6 minus minus 3. That's the gradient of PQ. This works out to be 5 minus minus 4 is 9. Minus 6 minus minus 3 is minus and minus give you plus. So that's minus 6 plus 3, which is minus 3. It's a 9 over minus 3 is minus 3. That's the gradient of PQ. Gradient of PQ is minus 3. Now that we get the gradient of PQ, we can find the midpoint of PQ. And the midpoint of PQ is, to find the midpoint of PQ, it is going to be this right here. Minus 6 plus minus 3. Minus 6 plus minus 3 divided by 2. Minus 6 plus minus 3, comma. Then we have y1 plus y2, which is 5, plus minus 4. And then this is also divided by 2. And when we divide this by 2, that will give us the that will give us the midpoint. My apologies. And so the midpoint of PQ is minus 6 plus minus 3 divided by 2. That's negative 9 over 2, comma. Now 5 plus minus 4, 5 plus minus 4 is 1 over 2. So that's 1 over 2. That's the midpoint, 1 over 2. This is the midpoint. Now that we have the midpoint right here, and this is the gradient of the line PQ. This is the gradient of PQ, and this is the midpoint. Then what that means now is gradient of PQ, midpoint, we need the bisector. So the gradient of the bisector of PQ is going to be minus 1 over the gradient of PQ, because the bisector is perpendicular to PQ. So the gradient of the bisector is 1 over 3. So the equation of the perpendicular bisector of PQ is going to be given by, let's write it down. So the equation of the perpendicular bisector of PQ is, let's find the equation of the perpendicular bisector. The equation of the perpendicular bisector is y minus a half, y minus the y value, y minus a half is equal to minus 1 over 3 into x minus, this is now x minus 9 over 2. So that's now x plus 9 over 2. Yes, yes, x plus 9 over 2. So what we're going to get now is y is equal to, that's minus x over 3, push here, plus 9 over 2 plus a half, but this is minus 1 over 3 times 9 over 2. It's really difficult when you have this many fractions, so use a calculator. All right, sometimes it gets a little confusing with fractions, so I bring over the half to get plus a half. So it works out to be minus x over 3 minus 1. Actually, this works out to be minus 1. It can be a little rough with fractions, but this is the bisector of PQ. So now we need to find the bisector of PR. So let's do that in a different coloring block, and let's do it in a little box right here. Don't want to be wasting page, so we'll do it in a box right here. So first thing we need to find is the midpoint of PR. So the midpoint of PR is going to be equal to, finding the midpoint of PR, minus 6 plus 2 is minus 4. So minus 6 plus 2 divided by 2. So the midpoint of PR x coordinate is negative 2, comma, 5 plus 1 is 6. 6 divided by 2 is 3. So the midpoint of PR is negative 2, 3. Now that we get the midpoint of PR, what else do we need now? So we have the midpoint of PR. Now what we need is, so that's the midpoint of PR. Now we need the gradient of PR. Now the gradient of the PR is going to be equal to y2 minus y1. Gradient of PR is y2 minus y1, 5 minus 1, over x2 minus 6 minus x1 of 2. So that works out to be 5 minus 1 is 4, minus 6 minus 2, minus 6 minus 2 is minus 8. And so 4 over minus 8 is minus 1 over 2. So that's the gradient of PR. Now that we have the gradient of PR, then the gradient of the bisector of PR is going to be positive 2. And so the equation of the perpendicular bisector is y minus 3 is equal to negative a half in bracket x plus 2. So now to make y the subject from here, we would get that y is equal to, that's, oh, my apologies. I used minus a half here when I should have been using 2. Gradient of the bisector is 2. So that is 2x plus 4. This is y equal 2x plus 4, but I bring over the 3 to get 2x plus 7. So these are the two perpendicular bisectors. These are the two bisectors. But remember what we said. We said that the center of the circle intersect where the two bisectors meet. So let's write that down. The center of the circle intersects where the two bisectors meet. So since the center of the circle intersects where the two bisectors meet, what we're going to do is we're going to equate these two equations. So y equal minus x over 3 minus 1. So y is equal to minus x over 3 minus 1. And the next one is, I think, y equal 2x plus 7. So y also equal to 2x plus 7. All right, now that we have that, let's solve them simultaneously. So equating the two of them, we're getting minus x over 3 minus 1. That is equal to 2x plus 7. Now what we can do is group the x on one side and group the number on the other. So bring over the 1 over here to get 8. Bring over 2x over here. So we have minus x over 3, which is minus x over 3 minus 2x. That is, let me see, 2 can be written as 6 over 3. So that's minus 7 over 3x. This is minus 7 over 3x. That's equal to 8. Multiply through by 3. Is that right? Let me check again. Just want to make sure. Something looks a little off. Just want to check to make sure we didn't make any error. Yep, there was a slight error made because I know something was off. So 1 over 3, this should have no minus here. This should have no minus here. This should be 1 over 3 times 9 over 2 minus a half. This should be plus 1. It doesn't affect it too much. It should be plus 1. X over 3 plus 1. Doesn't affect it too much. It should be plus, no minus here. It should be, yeah. So this should be plus. This should be no minus here. No minus here. So let's look at this again now. Let's redo that. So we bring over this now. So let's bring over the x over 3 to this side. So 2x minus x over 3, that is 5x over 3. Then we'll bring over 1 over here to get 1 minus 7 is minus 6. Yeah. And so we get 3 times, is that right? Bring over 7, we subtract 7, 1 minus 7 is 6. 6 times 3, but that's not right. This is not lining up to be. Let us see. Midpoint is minus 9 over 2.5. This is good. Midpoint here is minus 2, 3. This is good. Did we go off with the gradient? 5 minus. So this should have been 5 minus PQ. 5 minus minus 4 is 9. Minus 6 minus minus 3. Minus 3, this is good. Midpoint is minus 6 plus minus 3. Divided by 2, 5 is that is, yep, 1 over 2, this good. This good. 1 over 3x. This is now 9 over 6. 9 over 6 plus a half. That is it. So as you can see, you have to be extremely careful. That's why I always emphasize with fractions. You have to be really careful. This is so difficult with fractions, that is too. See how many times I have to recheck it? That's why I rarely do it this method. I prefer method 1 because fractions, you have to be extremely careful with them. I can never go wrong when I do it using method 1, equating the radius. I don't work with so much fractions. So now we can go again. So this become minus 5. Then we cross multiply to get minus 15. Minus 15 equals 5x. Then we divide through by 5. And now we get our x equal negative 3. After we get x equal negative 3, we can go ahead and find y by plugging in negative 3 in here. So plugging in negative 3 right here, 2 times negative 3 plus 1. If you're to plug it in here, you're going to get that y is equal to 1. Now that we find the center of the circle, then the radius r is going to be equal to the distance from the center. So this is now the center. The center is negative 3, 1. So the radius is equal to, radius r is equal to CP, right? Where P was the point, negative 6, negative 5. All right. So now what we're going to get for the radius is CP is the square root of, so this is C. C is negative 3, 1, and that is P. So it's going to be x2 minus x1. So it's negative 6 minus 3 square plus minus 5 minus 1. So minus 5 minus 1 square. We work these things out to get minus 6 minus 3 square plus minus 5 minus 1 square. P was negative 6, negative 5. Just want to make sure. P was negative 6, 5. P wasn't negative 5. This was 5, 5, 5. So negative 6 minus 3 square plus 5 minus 1 square. So we get the radius is 5. So after doing this method, method 2, we still get that the equation of the circle is x minus the center, which is x plus 3 square plus y minus 1 square, and it's equal to r square, which is 5 square. So we still get the same answer doing it method 2. Nice and easy, soft. We still get the same thing from method 2. All right. So that is that. We still get the same answer. Now, of course, I'm going to show you everything that we did in terms of the bisector and stuff like that. I'm going to show you what really took place. So let's go back to the circle. So going back to the circle right here, I'm just going to show you what's going on again. So let's go to graph, rectangular grid, and we're going to put in this circle. And remember, the circle had negative 3, 1 as the center and a radius of 5. That's 3, 4, 5. All right, this was the point. I'm just going to put on the points them again. All right, so this is what we had. This point right here was R. I'm gonna show coordinates, label it as R. This was R. P was minus 6, 5. minus 65 right here. This was P, show coordinates. This was P. Of course, I need to round them up. As you can see, it is to 2 decimal place. Let's fix it. Let's put it to no decimal place because I didn't do it perfect. So let's put it to no decimal place units. All right, so put them to units there. They look better now. Now we need, where was Q? Q was -4, -3, -4, somewhere of that sort. -3, -4. This was Q. This was Q. Now look what we did. We found the bisector. So let's move. This is Q. Look what I'm going to show you now that it's justified. Remember we said that the center is -3, 1. This is the center. Look at this now. Now we found the equation of the bisector, perpendicular bisector of PQ. We found the bisector of PQ. So I'm going to show you the bisector of PQ, x over 3 plus 2. Look at this line. You're going to see it pass through the center. Go to graph. I go to plot new function. I'm going to plot the function x over 3 plus 2. Look what happened. It passed through the center. This line that we just draw is actually the bisector of PQ. This line right here is the bisector of PQ. All right, and look at this. This angle is 90. All right, I need able to show that it's 90. It's not drawing as smooth. So that's the bisector of PQ. Next we found was the bisector of PR. So this is the line P to R. And I'm going to draw the bisector of PR now. And the bisector of PR was 2x plus 7. So I'm going to insert that line. Plot the line 2x plus 7. Look what happened. Pass through the center. Notice that the bisector, the two lines in purple do what? Notice that the bisector, this first purple line is the bisector of PQ. The bisector of PQ, notice that it passed through the center of the circle. And the bisector of PR right here, the bisector of PR also passes through the center of the circle and then they intersect right here. The two bisectors intersect at the center of the circle. So always remember that if you have 2 points on a circle, then the bisector of the line of those 2 points pass through the center of the circle. So that's why we could have found the two equations of the bisector, equate them to find the center. Once we find the center, then we can always find the radius, because the radius is from P to R is the radius, from Q to the center is the radius, from R to the center is the radius. All right, so that's how we do this question, doing it method 2. Easy, soft.